Hi, my name is Ramona Walls, and I'm at Cyverse at the University of Arizona. I'm going to talk to you today about describing microbial environments with ontologies. This is a very high-level and quick overview. It's presented as part of the Microbial Future Phi workshop happening in Chicago in 2016. And describing environments can't necessarily be done with one single ontology. It often takes several different components, though there is one ontology that is really primary in describing environments, and that is, of course, the environment ontology, or ENVO. If you are interested in describing environments, I highly recommend that you go to the ENVO website shown here, environmentontology.org, and that you read the latest paper that just came out on ENVO that's linked from the website as well. There were some components of ENVO that were missing for a particular project when we were trying to describe microbial environments. And so a group of us here at UA began work on the microbial environments described using OW or MEOW, and you can see the GitHub site for that. Finally, the biological collections ontology is used for connecting observations to the entity and the resulting data that really lets you work with ontologies in a practical way for describing environments. So let's start with a discussion about ENVO. This is from the ENVO website. You can go and you can click to choose. You can click to view the roots of the ENVO, or the most upper level classes. And the three key classes for ENVO are, of course, environmental feature, environmental material, and environmental system. So how are those used in actually describing data? Well, we use subclasses of those, or more specific classes of features, materials, and systems. Suppose, for example, we had a paper where it was described that samples were collected from fast-moving reaches of a freshwater stream and filtered using something to extract the microbes, etc. How would we associate that with environment ontology terms? Well, we could start by searching ENVO for terms like reach or freshwater stream. So reach, if we did a search for that, would come up with the ontology class watercourse, of which reach is a synonym. And you can see by following the little the flow of arrows, arrows up to the top, that a watercourse is a type of environmental feature. We might also discover fresh water as one of the ENVO terms, and again, following the arrows, you can see that fresh water is the environmental material from which your specimen was collected. And in terms of the system, we have a freshwater river biome. Again, that's the environmental system. So we've hit on each of the three key branches. And one of the nice things about ENVO is that the logical definition of freshwater river biome already tells you that it has fresh water and a watercourse as part. So the feature, material, and system are linked through the logical definitions embedded within ENVO. However, we often want to do more in our description. Suppose that you also, the researcher also took some water samples and wanted to understand the water chemistry in which the communities were occurring. So they might have a description that says unfiltered samples were analyzed for dissolved organic carbon, dissolved organic nitrogen, total dissolved nitrogen, etc. ENVO does not currently have terms to describe all of these, and so we needed these are the kind of terms that we really needed for the iMicrobe work, and that's why we began working on the MEOW ontology. MEOW was defining what we call environmental parameters, and here's just an example of one, which is the total dissolved nitrogen concentration. And so it's a concentration, which is a quality that adheres in or is a quality of some fresh water, and it's towards some nitrogen-containing molecule. It's a bit of a strange construction for someone who doesn't work with ontologies, but it does actually get the query results that one needs when one is working with the ontologies. Just to note here that this is not a real, I just kind of threw together a hypothetical hierarchy for what a nitrogen-containing molecule is. In reality, we would use the CHEBI, or the chemical entities of biological interest ontology, for describing total dissolved nitrogen. So we started building logical definitions like this for the MEOW project, but we did not actually continue to develop those in great detail. Our primary work was in mapping across different vocabularies for these terms and setting up the original design patterns for them. Because since we started working on iMicrobe, ENVO now includes environmental parameters or environmental qualities as part of its hierarchy. So rather than continuing development of MEOW, we're going to work with ENVO to get these classes into the environment ontology and be able to use them from there. So this is kind of cool, looking at these graphs and how logical terms are defined logically, but that's not how people actually collect data, right? We actually collect data in spreadsheets that has columns for things like specimen ID, location, nitrogen concentration, carbon concentration, et cetera. And so how do we go from that spreadsheet to an ontology and back and forth in a way that's useful and helpful to researchers? So that's the work of the biological collections ontology. And before I show you an example of that, I need to digress very quickly into a little bit of ontology vocabulary and talk about the difference between instances and classes. And hopefully Corinne has not already explained this in a previous presentation. But everything that I've been showing you so far in all of the boxes that have been labeled are classes. Classes are essentially generalizations of a particular type of entity. So we have a class called specimen collection process that that can be used to describe any specimen collection process. And then any actual process that happens in the real world, which we might label sampling process 1, is an instance of that class. Likewise, there's a class called specimen, but an actual sample that we've collected in the world called water sample 1 is an instance of the class specimen. And so what we've been working on for the past couple years with the BCO is methods for converting between spreadsheets and graphs, basically taking data that's collected using spreadsheets, using that to automatically generate instances of classes of different ontologies, and then being able to build a graph that relates the instances to one another through the logical structure that's defined within the ontologies. So here's just an example of some instances that would come. We would have a spreadsheet that would be listing, the sampling process, the water sample, and the community. It might not actually explicitly list the sampling process, but it will list a date. And because there's a date and a sample, we know that some sampling process had to occur. Because we know that the water sample was of seawater, we can describe that as the input as the instance of the ENVO class of seawater that's part of some marine biome. And so that's essentially what the kind of work that the BCO is used for. And I'd like to end by thanking various contributors and collaborators on all of these ontologies. I am not by any means the primary person who does work on ENVO. The bulk of the credit goes to Pierre Buttigieg, and he's the maintainer and main editor for ENVO. Chris Mungle is also very heavily involved in ENVO work, as are a number of other community collaborators. The iMicro work out of University of Arizona is done with Bonnie Hurwitz and Ken Ewens-Clark. And the BCO work, again, has made a community of collaborators, but I particularly like to call out John Deck, Rob Goralnik, and John Wichorek. And thank you, and I'm sorry that I'm not there to take questions in person.